One of the most common precipitation reactions is called a metathesis reaction. These are also called exchange reactions or sometimes double displacement reactions. And we can write this in the general form as AX plus BY becoming AY plus BX. And here, each of the species that were reacting together kind of change partners. And typically we observe this in solutions. So if we wanted to write an example of such a reaction, we could have sodium chromate, which is Na2CrO4 in aqueous solution, plus 2 silver nitrate, which is AgNO3, also in aqueous solution. When this reaction takes place, our products are 2NaNO3 in aqueous solution, or sodium nitrate, plus silver chromate, which is Ag2CrO4. And this is actually going to be a solid, which we can predict using the solubility rules. So this is an example of these metathesis reactions, and really what we need to consider here is a way that we can show this reaction and the way we can communicate this reaction to another chemist that shows all the chemistry that's happening. And the way that we do that is referred to as net ionic equations. And this shows the chemistry that's happening at the molecular level, and we represent this in an equation form. So when we write this net ionic equation, and we're going to use the example that we have displayed here, we can go through and use a couple steps to do this. Number one, we're going to break up all aqueous species into ions. And what that's going to do is that's going to show that what they actually exist as in solution. The second thing we're going to look at is we're going to keep any solids or precipitates as they are. Because at the molecular level, these ions are forming an insoluble solid, and we're actually going to see that solid in the solution. So we don't have ions anymore. We have an actual solid. So let's use the example given above. When sodium chromate breaks down in solution and forms ions, it's going to give us 2 sodium plus ions in aqueous solution, plus 1 CrO4 2- ion in solution. The silver nitrate is going to break down into 2 silver plus ions in solution, plus 2 NO3- ions in solution. So these are all our reactants, and these are the ions in aqueous solution. So what happens is, when each of these ions come into contact with one another, they could either stay ions in solution or they could form a precipitate. The solubility guidelines are going to help us predict what's going to happen in that particular reaction. When sodium and silver, 2 cations, they're going to repel each other, so they're never going to form a precipitate. But the question is, will sodium form a precipitate with nitrate? If we look at the solubility guidelines, all nitrates are soluble, and a precipitate will not form. But a precipitate will form when silver plus ions come into contact with chromate 2- ions. So we can express the products as 2 Na plus in aqueous solution plus 2 NO3- also in aqueous solution plus the Ag2CrO4 solid, or the precipitate. The next step in a net ionic equation is to cancel out all spectator ions. And spectator ions are ions that go through a reaction unchanged and appear on both sides. So This reaction that we have written here is what we refer to as a complete ionic equation. It shows all species that are involved, and it shows the identity of those species, whether we have an aqueous solution or a solid. What a net ionic equation is going to do is it's only going to indicate the ions and precipitates that are involved in the chemical reaction. Okay, so we can kind of list these and cancel out what we call spectator ions, which in this case are going to be the 2 sodium plus and the 2 NO3 minus on each side. Okay, so we cancel those out, and what we're left with on the reactant side is 2 silver plus in aqueous solution plus CrO4 2 minus in aqueous solution, giving us Ag2 CrO4 solid. So when we're looking at this, and this, what I have written here is the net ionic equation. So the difference between a net ionic equation and a complete ionic equation is that in the net ionic equation we only show the species or the ions and molecules that are directly involved in a particular reaction. Okay? And we use this, and we use these net ionic equations for a couple things. Number one, the net ionic equation generalizes the reaction. So in general, we can say that any solution that contains silver plus ions and chromate 2 minus ions will form a precipitate. So we can look at it in that way. The second thing that it does is it focuses the attention on the change that is occurring. In this process, we have ions in solution that are going to react together to form a solid. So the change that happens in this solution is going to be that change where we have silver ions in solution and chromate ions in solution that are going to react together to form that precipitate. So the guidelines that we're going to use to write out these net ionic equations and figure out which solids will form are going to be governed by these solubility rules. So make sure you familiarize yourself with table 4.1 and know how to use that to predict whether or not a particular solid will form or if the ions will remain in solution.